Hi, welcome to CCSP Domain 2. This domain is split into two parts and this tutorial is focused on first part. Please subscribe to the channel if not yet done. Cloud data lifecycle phases. So who are responsible for the data in the cloud? Basically, the CISO, CSO, CTO, security administrators, and then the architects who are designing the network, who are designing the security of the data deployment in the cloud. They are responsible. They remains responsible for the security of the data. Who is the owner? Basically, who owns the information and responsible to define the controls and policies. They are the data owners. From exam point of view, remember that the data owners do not apply control, they do not take backup. They are defining the security controls because they knows that what all compliances they need to achieve and what all security policies they need to define for their data that they are responsible for. Similarly, the data custodian, they are responsible to apply those controls which are defined by the data owner, and they are responsible to take backup, to restore the data, to continue with the services. The data custodian is responsible for that. So in the data life cycle phases, we have different different phases. Like in create, we have to classify the data, we need to categorize the data, we need to tag the data. Here also we need to ensure that how it is categorized, because anything that we miss here in the create part, if we do not properly classify the data, if we do not tag that, if we do not categorize that, then ultimately um, we will be losing in the next life cycle phases of the cloud data. Because anything, if we do not properly classify the data in the create phase, possibly we will miss to encrypt the data, and we will miss to apply the access controls here, and we miss to monitor that data probably here in the next phase of the life cycle of that data. In the store, we need to ensure that the data while it at rest and it is encrypted, we apply proper access controls, we perform the logging, so that we knows that who has accessed and when it was accessed, and we monitor the properly that data. While the data is in use, we apply proper data loss prevention control, IDLP, read only. We keep it as read only. We perform rights management on that. During the share phase, we apply DLP, we encrypt it, and we apply IRM. In the archive phase, it is important to encrypt the data because we don't know that for how long we are going to retain this data, and it is important to encrypt that based on the sensitivity or based on the classification of that data and based on the retention policy of that particular organization. In the destroy phase, we overwrite the data when the data is in cloud, because we do not usually manage the hardware, we do not have physical access to the resources so that we can degauss, or we can perform the any other sanitization on the media. But we are left with only with the overwriting and the crypto shredding. When the data is confidential and it is higher in the classification, then it is the best solution to perform the crypto shredding when it comes to destruction, and we don't need that data anymore. Data mapping, location and the access of the data are the two important aspect. We need to see whenever the data is being generated on prem, or even if it was migrated from the from the on-prem to the cloud, or even further distributed. We need to take care of that, who all has access to the data, what all potential locations where the data need to be protected, and where the data is being stored, what all regulations that we need to take care of, what are the controls in each location, what are phase of the life cycles that are um, uh, you know uh, data moves between the locations, and what are the channels which are being used to move that data, and who all will be accessing that data while access the data. So this is basically, it is not similar to the traditional way of access. Basically, when the data is in cloud, it is more attribute based access. Who is accessing, from where is being accessed, and what is the IP address of the accessor, whosoever is accessing that data, and what time it is being accessed. So all of these things are supposed to be there in the access of the data. Other important aspect here is here are the function, actor, and controls of the data. Function means what can be done with that data, what all functions. For example, can you process that data, can you archive that data, can you modify that data, and who all can access is the actor that we need to look at it. And control of the data, whether you apply encryption for confidentiality, you apply rights management for to protect against any unauthorized access, and you accordingly you define the controls, whether it is preventive, detective, or corrective controls. The other key data functions are here, like the access, process, and store. So access means anything related to view, access the data, including copy, file transfer, any other exchange of the information. So the process means perform a transaction. It could be when you are creating the information or when you are using that information. Similarly, for the storage, whether this data is being stored for the short term or for for the long term data, and that is something in the store. Data dispersion is the important concept for the cloud data security. So here we used to have earlier in the traditional infrastructure RAID, which is the redundant array of independent disk, which was primarily used to achieve the resiliency, as in on-prem infrastructure at the server level, to achieve the redundancy. But the data dispersion is more focused on the security, which improves the security of the data, as well as to achieve the resiliency at the cloud level. In the private clouds, you configure this yourself in the storage level. The data dispersion also, we have here, there are two techniques. One is the bit splitting, and another is um, the erasure coding here. So in the bit splitting, it is like the adding the encryption to the RAID, where the data is first encrypted and then is split into the PCs, and then these PCs are distributed across the several storage areas. We have at the same time we have couple of disadvantages of the bit splitting. One is the processing is CPU intensive, because if you take one computing resource, and if you use the bit splitting, then it is going to consume a lot of resources and CPU there. Availability concern, all parts of the data which needs to be available, first this has to be decrypted, and then we need to use that information. That is again the CPU consuming activity. Storage requirements and the costs are higher than the other storage system if we use it there. There are two different encryption methods in the cloud to support the bit splitting. Another one is SMSS, secret sharing made short. Another is AONTRS, which is all or nothing transform with Reed Solomon. So in SMSS, there are three phases for the process. One is encryption of the information, use of the information dispersal algorithm, and then splitting the encryption key using the secret sharing algorithm. So three things, three phases in SMSS. Number one, encryption of the information. First, we have to encrypt the information that we want to split, that we want to disperse, and then use of the informational dispersal algorithm. We need to apply the dispersal algorithm, that this is how exactly this is going to disperse. Then we need to split the key using the secret sharing algorithm, so that we can share, we can secretly share the key. And in the second method, which is AONTRS, this is all or nothing transform with the Reed Solomon. This method first encrypt and transform the information, and then and the encryption key into the blocks in a way that the information cannot be recovered without using all the blocks. And then it uses the IDA to split the blocks into shares, and then distribute it to the different cloud storage services. Then we have the erasure coding, which is good for the latency tolerance, large capacity stores. This is like using the parity bits for the RAID stripping. So in RAIDs, the parity bits help you to recover the missing data. If one strip derives get lost, the eraser coding help you to recover the missing data if a cloud data is unavailable or lost while your data is being dispersed. At the same time, this allows for the failure of two or more elements of the storage array. Thus, this offers more protection than the RAID. This is more commonly referred as a chunking. This is also, known as the chunking. And if we use the encryption, then it is referred as the sharding. So remember these terms. If you apply the encryption during eraser coding, then this term is known as sharding. Okay, data storage architecture. So in the data storage, we apply the data storage at infrastructure level, then platform level, and then we have software as a service level. At the infrastructure as a service level, we have volume or block, which encrypts or which stores the data. In the virtual hard drive, which is attached to the VM. For example, EBS, VMware Virtual Machine File System, VMFS, and then Google Persistent Disk. Similarly, for the object, this is similar to the file share access via API or the web interface. This is on Amazon S3 or Azure Blob Storage. Platform as a service, we have two things here. One is the structured data, and another is the unstructured data. The structured data is which is the information with the high degree of organization, which can be found easily within RDBMS. Because in RDBMS, we have different tables, different columns, and different rows, right? And we split this information. We have the different key, and we have primary key, foreign keys, and you can easily run the query and fetch that information. And that is why this is known as the structured information. While the unstructured information is which is not stored in the traditional RDBMS, the information such as email, word, context, media content, these are all unstructured information. Software as a service, we have different content here, like information storage and management, like the data entered in the system via web UI or now stored in the database. Similarly, the content and file storage, like file based content is stored within the application. Then we have ephemeral storage, means short lived data which has no existence for longer. Then we have content delivery network. For example, for content delivery, like you have mirrored servers, like you are accessing some media content from Netflix. While in India, you may have some local servers from where you are fetching. That is why you will get the good performance. Somebody who is accessing the data in North America, they may have some other mirror to fetch that data. So that is the content delivery network. Row storage, this is an option in the VM server that enables the storage logical unit number to be connected to VM from SAN, for example. Long-term storage, some cloud service providers, they tailored the services to store archive data that is enterprise can access by using some APIs, and that is known as WOM, like write once, read many times. So that is also WOM, that is write once, read many. So this is the different terminology for long-term storage. Threats to these storage types, like unauthorized usage or access. There are two kinds of threat agent here. One is the insider, another is the external. So insider threats are related to the unauthorized access. So how you can manage, the CSPs can manage with these is through the multiple parties which can be involved to approve the access to the data. While in the external, this can be managed using, to avoid any malware, to gain escalated privilege, to, using phishing techniques to steal the credentials from the user who have credentials to access the data. Data leakage and breaches, if the cloud providers are not paying enough attention how to replicate the data, whether it is protected or not, the customers should know that their data is secured consistently across the locations, not only for their peace of mind, but of course the regulations as well. Then we have DOS, denial of service. It has the huge impact on the availability of the information. Then we have the corruption or the loss of the data affects the integrity and availability of the data, which may impact further the specific data and the storage. When we talk about the durability and reliability, it is the concept of using the redundancy to ensure that the data is not lost, compromised, and corrupted. Encryption and key management. We have this encryption and key management is very important for protecting the data in the cloud. It is important to remember that no physical isolation and segregation in the cloud. You are using the common services. You are on the multi-tenant infrastructure, and just keep that in mind whenever you are storing the data in the cloud and applying the security controls and storing the keys and applying the encryption algorithms there. So just keep that in mind. There are different challenges here. If the data is encrypted, you cannot perform the data analytics. It is quite difficult. When you are sharing the common server, when you are on the multi-tenant infrastructure, you need to take care that your keys are not being accessed by the other tenant on that infrastructure. Encryption is costly. It will certainly impact the performance. Encryption failure may impact the availability. For example, you lose the key, or you do not, or you fail the encryption algorithm, you will not be able to access the data. There are three important component in the encryption technology. One is, for example, the encryption engine. So this is, of course, the important aspect. Another is the key which is applied, and third one is the data. Okay, so these three components are the core of the encryption architecture. Encryption in IaaS, infrastructure as a service. Two types: basic storage encryption and the volume storage encryption. When we talk about the basic storage level encryption, it means that the keys are in the custody of the cloud service provider, And this can of course protect from the theft or loss, but it cannot protect from having, you know, CSP's admin access to the data. They can always access the data, which is another issue. Volume storage encryption. In this, the encrypted data reside on the volume storage. Different aspects here. This protects against the physical loss or theft, external admin access the data, snapshot of the storage level backups being taken and removed from the system. When you are using the VMs, so VMs can be snapshots, and those snapshots might have your data, and this can protect against those. Different methods to implement, to apply the encryption at the storage level: instance based and proxy based, and then we have the object encryption. So this instance is when the encryption engine is located in the instance, keys are managed externally, while the proxy means data engine running on the proxy instance. It handles all the cryptographic actions. When the data is leaving the proxy server, it has to be encrypted. Object encryption, it is the majority of object storage services offers as service server side encryption. This is less effective because if it is server side, then probably the cloud service provider has access to your key, and hence they can access your data. Database encryption, file level encryption. This encrypts the volume or the folder of the database with the encryption engine, and the keys reside on the instance. While on the transparent encryption, this is at the granular level. You can encrypt the particular column, you can encrypt particular row in that particular database tables, and this is more at the granular level. Application level encryption. The encryption engine resides at the application that is utilizing the database for the encryption purpose. There are different challenges with the key management. Access to the keys. They should not be accessible by the cloud providers. Key storage, secure key storage difficult in the cloud, and you need to find out the different ways whether you want to manage the keys in the on-prem or with the different cloud provider, or how exactly. Basically, the idea here is you need to split the data storage and the key storage. This should not be there in the same with the same cloud provider. Backup and replication, it might affect the ability of long and short term of the key management. But yes, how long you want to retain the data, you want to manage the keys for that period of time. Key storage in the cloud, basically three different aspects here. The CSP managed, whether CSP is managing your keys or externally managed. The keys are maintained separately from the encryption engine and data. Managed by third party. So these keys are managed by with the key escrow services. Key escrow services is that you have multiple custodians. Some third party is holding the keys, and with the key escrow services, like without your access, without your approval, they cannot use your keys. Software based key management, this actually doesn't meet the physical security requirements, because especially when it comes to the government data in some countries. For example, in US, if you are dealing with the US government data, then you have to comply with the NIST, that is FIPS 140 level 2 or level 3, for example, and you need to take care of those kind of physical security requirements for the key management perspective. Important considerations for the for the key management, like key generation, um, key distribution, storage, and restriction. So in generation, where you are generating, you have to generate the keys in the trusted appliance or trusted source. So this origin has to be very strong. It depends, what kind of hardware you are using, or whether it is FIPS approved or what. Distribution, it's important that the encryption keys are distributed securely to prevent the theft or compromise during the transit. The storage key must be protected at rest. Especially you may want to use the HSMs, like hardware security modules. This is a physical device that safeguards the encryption keys, and sometimes it is the requirement when you are evaluating the cloud service providers. Just check what HSM capabilities they have, what kind of FIPS levels, like FIPS 140 level 2 or level 3 they are offering for storing the keys. Key destruction is the removal of the encryption key from its operational location. When you don't need that data, you don't need that key, you can destroy that securely. There are other data security technologies like hashing, masking. Hashing is a one-way function. This generates the fixed length output. No crypto key is required. Good for malware and accidental changes. But of course, this is not good for the intentional changes, because anybody can change the data and can recompute the hash. Masking is the other concept. Masking is when you just hide the partial data or the digits in a particular data. For example, here we have credit card number and we have masked some digits, and only 4 digits for the customer verification can be used. There are other concepts here: substitution, scrambling, or nulling. In substitution, we replace these digits with some other digits. In scrambling, we change the position of those digits. Nulling, we just keep that area blank. For that, tokenization is when the substitute sensitive information with the alternative number, and that alternative number derived cryptographically, that is known as the token. So this token, for example, the credit card information. If you don't want to travel or share the same credit card information for your business, you can generate the token and just use that in place of the original credit card information. Obfuscation is a process of hiding the sensitive information like critical source code, keys, PII, or any other data which is hard coded, for example, in the source code, and you want to obfuscate that. That is where the obfuscation is used. De-identification and the anonymization. This is where we remove the direct identifiers. For example, you have a form, and in that form you have a lot of information which is filled in, and if you just remove the name, email ID, phone number, any direct identifier, it becomes de-identified data or anonymized data, because you don't know to whom these information belongs to. Data loss prevention, very important concept, also known as the data leakage prevention. This is a set of basically the technologies and practices used to identify and classify the sensitive information. There are three core components in DLP. First is the data discovery and the classification. This is very important phase of, or the component of the DLP, because if we are not discovering the data properly, if we are not classifying that information properly, then probably we are going to miss the monitoring and enforcement on that data. And if that data is sensitive, then we will not be applying proper security controls, and we will not be monitoring and enforcing the policies on that data, and we might lose that data. Monitoring is possibly we will be monitoring for ingress and egress based traffic. Cloud based DLP solution is also known as DLP as a service. There are different solutions, and monitoring is usually on storage devices, on the devices which are processing the information, accepting, receiving the information from any other servers. Enforcement, this includes blocking of the data, detect and alert on the policy violation. It encrypts the data before leaving the network. That is one example of the policy, or we can say the enforcement. There are different data states in the DLP. So DLP can be applied at rest, in transit, or in use. when the data is at rest, the DLP implementation is stored wherever the data is stored, such as workstations, file servers, or any other locations. While in the transit, for example, when the data which is being transmitted, it is using HTTP or HTTPS or any, let's say, FTP or SMTP or any other protocol. So this data is supposed to be protected. For example, if the data, if the DLP is monitoring and the traffic is encrypted, you will need to integrate the encryption and the key management technologies into your DLP solution, so that you can open the packet and you can check what kind of data it is, and you can properly classify that data accordingly. Data DLP in use, so this is host based or any endpoint based. DLP is data loss prevention that is involved at the installation of the DLP application on the workstation. Some important considerations for DLP when it comes to the cloud. Data in cloud tends to move and replicate, so you need to take care where the data is going, how many clouds are involved, admin access for the enterprise in the cloud. That could be tricky because you are the customer and you are using the services from the cloud provider. DLP technology that can affect the overall performance. So keep in mind from the exam point of view, two things. One is the DLP and the encryption. So both can affect the overall performance of your infrastructure. Remember for the exam, as both these can affect the security, not security, it is the performance. The both can affect the performance. So from exam point of view, there is a trade-off between the performance and the security that you need to take care of while attempting the exam. Data discovery, it is a process of finding and identifying the sensitive information. The what is the goal basically of the data discovery? um, it is, it is to find out the meaningful data that has value to that particular organization. So how many approaches are there? For example, we have the metadata, we have label and content. In the metadata, this is data about the data. For example, any table which has information about the data which is being discovered, and you store that data, or you basically discover based on that metadata. Let's say you may have header file, or you may have any other file which keeps the information about about that data. So that is metadata. Labels, marking that describes the data. For example, in the documents, you may find in the header and footer, and you have some labels, or in the file names you may have some names. But usually in the title of the document or header and footer, these are considered as the labels which are marked and describes the data. And based on that, the algorithm identifies or discovers that data type. Content analysis, data is analyzed by the pattern matching, hashing, statistical. For example, Luncheck or Morton formula to find out any 16-digit number, whether it is a valid credit card number or not. So that is a kind of content analysis that is performed. Is structured data, any structured data, as we discussed in previous slide, it is related to RDBMS, where we have organized data in the form of tables, columns, and that has associated metadata. Unstructured data, this data can be text or binary, and usually this is much harder to discover and search. Data discovery issues, poor data quality, dashboards, hidden cost. Of course, we have these issues with that. For example, the data visualization is as good as the amount and quality of the data which is being fed. Dashboards, the data presented in the dashboard might not always be correct to rely upon. Hidden cost, hiring the data engineers, it is a hidden cost because these are very costly to run your project, and that is another issue with the data discovery. With this, we conclude this tutorial. Thanks for watching. I hope you liked the content in this tutorial. Please tell me in the comment section. Your colleagues might also need this, so just share the link with them as well so that they can take benefit. Also, please subscribe to the channel for regular updates. Thank you.